Hi Bio30s! In this video we're going to be talking about what a test cross is. When I'm talking about a test cross, I'm going to be using this in only particular circumstances when I have an individual that has a dominant trait, and we know that dominant traits, you only need actually one letter that's dominant in order to show the dominant trait. So I'm unsure about their genotype because they could be either homozygous dominant or they could be heterozygous, and maybe I don't have enough information to fill in that second letter. So we have an individual that has an unknown genotype because they're dominant, okay, and I'm going to try to figure out what their second letter is by doing a test cross. So anytime I do a test cross, I take another individual and I breed them with this dominant individual that I'm unsure about the genotype. The second individual always has to be a genotype that I know 100% sure, and the only genotype out of the three options, homozygous dominant, heterozygous, or homozygous recessive, the only one that I know for sure by looking at the organism is homozygous recessive. Because it's showing the recessive trait, the only option for them is to be the little letter genotype. So I'm going to cross this unknown individual with a homozygous recessive organism, and then I'm going to look and see what offspring they produce. And based on their offspring, I can figure out what their second letter is. So I'm taking a dominant individual, big T something, I'm not sure about their second letter, and I'm always going to be crossing them with a little t, little t. Okay, homozygous recessive, because that's the only genotype that I know. By looking at the organism's phenotype, I know their genotype has to be this. So we're going to go through a couple examples here. So the first example is looking at some offspring ending up with a recessive trait. Okay, so if I'm not sure about that second letter, I put all of my information into my Punnett Square, and I somehow end up with some of these recessive individuals being created. Okay, if this little t is coming from here, that means that this second little t has to be coming from the parent right here, that's the unknown. Okay, same with this one, this little t would be transferred over here, and this little t would have to come from this letter. Okay, so that means that this tall parent has to be heterozygous, so that means that this letter would be a little t. Okay, because you get a letter from each parent, and we know that the one parent is recessive, we're getting that one little t from the recessive parent, and that second little t has to come from the dominant parent. In the other example, we are looking at all of the offspring ending up with the dominant characteristic. Okay, so that means maybe I'm doing this 5, 10, 15, 20, maybe 50 times, and every time I'm doing it, I'm ending up with all of them being the dominant characteristic. So this time, again, I'm not sure about that second letter, but if I end up with all of my organisms having at least one big T, so they're showing off that dominant characteristic, this little t would be transferred to this box, so that means that that offspring would be heterozygous, and this little t would be coming over here as well. So this big T would have to come from the tall parent, so that means that we're going to say that the tall parent is most likely homozygous dominant, so they would have a big T right here. I'm saying most likely because even though I have sometimes two different options, so for the last example, I had either big T or little t as a 50-50 split, just like a coin. Okay, you have a 50-50 chance every time you flip it of getting heads versus tails. I could potentially land on heads every time I flip it, even if I'm flipping it 50, 60, 70 times, I could still potentially land on heads every time. So for this example, we can't say 100% sure that they're homozygous dominant because maybe they're heterozygous and we just happen to be landing on a big T every single time. Okay, so we can't say 100% sure, but we can say most likely if we're ending up getting these results and we don't see any short individuals showing up, it's probably going to be homozygous dominant, but we can't say for sure. So just to summarize those two crosses, the first one we had some recessive individuals showing up, so the parent had to be a heterozygous. If we have all of our individuals showing up as the dominant trait, so no recessive, it's probably homozygous dominant, but we can't say 100% sure, because again, it's always a probability. Maybe we're just landing on the dominant one every time we're flipping the coin, so can't say 100% sure for that one. So now let's do an actual example. Let's look at sheep. So sheep can either be black or white wool. And sometimes sheep ranchers, they prefer the white wool over the dark wool because it's a little bit easier to dye and easier to sell because it has a nicer texture. It's not as brittle. Okay, in this circumstance, white is dominant to the black, and the farmer is trying to figure out if they have any heterozygous white sheep. Okay, they don't want to have heterozygous white sheep because they don't want to end up with a black sheep because it's really hard to sell that black sheep. So they're in it for making money. They're trying to make sure that their herd is purebred white sheep, purebred meaning homozygous, dominant. So what could they do? Well, they could do a test cross with their white sheep to figure out if they're going to end up with any black sheep. So remember that white is dominant over black. I'm going to use the letter B to represent this. Okay, if the farmer does a test cross, they always want to pick a homozygous recessive to mix it with. So they would be using a little b to mix it with their white sheep. So that means that that sheep would be black. So it'd be a big B something, and we're combining it with a little b. And if we end up with any black sheep being born, that means that that white sheep was heterozygous. So if we set it up like this, we have our big B organisms being produced, okay, from that combination. But then we have a little b, so that means that this second letter would have to be a little b and be heterozygous. So if this farmer was trying to get rid of these, maybe he would sell these sheep that he ended up getting some black sheep born, or maybe he would just make sure he's not breeding them, okay, keep them for other purposes like grooming the lawn and other things like that, but he would not want to breed them if he's using those babies for wool. So that is how we would do an example of a test cross. We're going to be doing a couple more examples like this in class. So make sure you understand this concept, and this concept is really important to remember that when you're doing a test cross, you're always mixing it with a homozygous recessive, okay, looking for an unknown genotype that's the dominant trait. So that's an important concept to remember for you guys' Chapter 17 exam. So I will see you guys tomorrow. Have a wonderful day.